Welcome to another video from Lockdown Electronics with me, Bill. Now if you're somebody who thinks that nostalgia isn't what it used to be, well, I can tell you that this time you've come to the right place. Now about 55 years ago, something like that, at the age of about 10 or 11, I was given an electronic kit, a Philips electronic engineer. Now you may be familiar, you may not, and I've seen one or two of these for sale on eBay, and the cheapest I've seen has been £30–40, not necessarily complete, and some complete ones are certainly going for a great deal more than that, sometimes twice. Now I'd be interested, but not at that price. So I was very fortunate the other day when I wandered into our local cancer research shop to spot an electronic engineer box sitting on the shelf. So I went and had a look and discovered that, yeah, most of it was there. How much did they want? £6. Really no decision to be made there. So I'm very pleased to say I've got it. It's sent me on a ridiculous nostalgia journey on electronics. So let's start with having a look what exactly this is and what it was, and then we'll have a look at what we've got and what we can do with it. Little bit of background then, first of all. So the box I managed to obtain looks something like this, and although I can't remember which version of the kit I got all those years ago, it certainly had a box in that style. So I know it was these kits were produced in the 60s as well, but the box was a different style then. So it was definitely this era which I had the pleasure to play with as a child. Now inside the box there's various components. This photo, a lot of the components currently are in use on a circuit that I'm trying to build, which more of later on, but you get the general gist. And those two wing-like things are actually the metal frames that hold together the frame of the chassis. You can see on the centre picture of the front box there's a chassis with a couple of handles at the front, and that's what those two metal things are all about. So there's various bits and pieces. What else is in the box? Well, not surprisingly, there's the instruction book, and this displays the 1970s Philips logo, and this particular handbook is a bit different to the ones came with some kits. I'll come back to that in a moment. So there's the instructions. There's a number of cards which allow you to lay out the actual circuit. More of that in a while, but suffice to say there's a fair number of those. I think there's about 20 of them actually. We've got some front panels of various sorts that would also clip on the front, and there's probably about 8 or 9 of those. There's the Philips Guide to Junior Electronics. Now this is a book, and for a book that's, you know, at least 55 years old, it's remarkably all right. You know, it's okay. You won't find integrated circuits and microcontrollers in there, not unsurprisingly, but it contains sound and easy to read information, and the authors certainly well qualified to be writing this kind of stuff. There was a spares price list from May 1970 in there, and so that definitely dates it as at least 54, probably more like 55 years old, something like that. There's a double-sided A5 sheet that's got the spare list of the spare stockists. Remember, of course, back then there was no internet, so there was a list by county of the various stockists of components. A fair number of these were toy retailers, but there's also a fair number of electronics shops get mentioned, and I would imagine there aren't many of them, if any of them, around anymore, sadly. I did grow up in an age where an electronics shop was, I won't say it was common, but you knew where there were several. Now at the back of the instruction manual there is this little address inviting you to write in for spares to Philips Electrical Limited, Young Engineers Department. I don't know about you, but if I was a young engineer, I'd be very proud to have that on an envelope I was sending in for spares. But the thing to just note at the top there is the kits are marketed in the UK by Metoy Playcraft Limited. Now Metoy, defunct now, was originally a German company, and the founders, who were Jewish, came over to the UK in the 1930s to avoid persecution, and that company continued producing die-cast toys, the name being metal toy, Metoy, and they did distribute other things as well, clearly including the Philips Electronic Engineer, because the Electronic Engineer handbook top centre photograph was peculiar to the kits distributed in the UK by Metoy. And incidentally, in the 1980s, about 10 years after this, Metoy were instrumental in founding Dragon Data, because apparently the owners of Metoy thought it was worth getting into personal computers. Sadly, the Dragon 32, although it was a famous computer, it was also infamous in not being much of a success, but it won't be, it's not unique in that one. So that's what we've got in terms of the box and its contents. Let's just now go back to how this all works, and we'll see this in a moment in some video footage, but for each circuit there is obviously a schematic diagram. This is circuit C1. It's a radio, 3-transistor radio, medium wave, and for each schematic diagram there's a layout card, and you pop out the holes as has been done there. This card then rests on what effectively is a pegboard, and this pegboard has a number of spring clips that are pushed through from underneath, like so. They look like that when they're pushed through, obviously through the holes where there are holes in the layout diagram, and then there's a corresponding spring which pops over the clip and is then holds the clip in place. And to attach wires, that's simply a case of pushing the spring down and popping wire or wires through. And although some of the connections in this kit are obviously a little tarnished after 50 plus years, this, you know, for these were galvanized springs, were reasonably good connection for somebody who's just trying to build a little project to see how it works. They were also capable of holding multiple wires, as you can see here, and in actual fact the more connections that are on there, the harder the spring would push up against them, so theoretically it would improve the contact pressure. Now the transistors were mounted on small circuit boards. This is the underside of one, greatly enlarged, and there were two emitter connections. That's the bottom left to top right, you can see connected together, and then the base and the collector just had one connection each with those diagonal slots. And if you then look at a transistor mounted on the board, you can see here that you push down the transistor through the slot and then you pop the wire through, and the connection is made through the spring clip, and the spring clip pushes up against those round pads on the underside of the circuit board. So that's the transistors, and that's how the connections work. Let's now go and have a look at something on the bench. Okay, so I've got the leads here for my LCR meter, and I'm not going to go through every component. I'm sure that would be mind-bogglingly boring, but let's just have a look at how far I've got so far. So if we take something like this, this is what I would say is an original component. It's marked up red, brown, and if we pop that onto the LCR meter, just let it settle, it's coming up at 218 ohms. It should be 220, so I reckon that's pretty good, really. If we just pick a slightly higher value one, so this one is orange red. Let's see what the LCR meter makes of that. Yep, that's making 3.293 K, so 3,294 actually ohms. Should be 3,300, so I reckon 6 ohms is I can forgive them for that, for something that's 50 years old. Now these resistors have a reputation, so let's see what we make of this one. Marked up brown, black, orange. So let's just, and they are marked up as with a gold band, so theoretically 5%. Now that should be brown, black, orange, should be 10k. Actually coming up as 11.4k, so it's gone high. Just to be absolutely sure before I'm sounding too confident of myself. So if we go brown, black, orange, somewhere in here, yeah, it should be 10k. Do you like my Radio Shack resistor calculator? I've had that most of my life. It's getting very worn now, but does the job nicely. So that should be 10k. It's actually coming up as 11.4, so that's definitely out. Need to replace that. And then these two, which are yellow, violet, orange, that's going to be 47k. Let's see what we've got for those. Yeah, it's coming up as 55.8, so that's well up. Let's try this one again. That should also be 47k. That's coming up as 52.5. So yeah, those resistors are definitely going to need replacing. That's not too difficult. There was no light dependent resistor, but I've got a few of those, so I've popped that one in. There was no diode that was missing. It's a germanium diode supposedly in the kit, so this is a germanium diode that I've got. And a lot of applications you'd get away with a silicon diode, but just be aware of, you're probably aware there's quite a difference in forward bias voltage. Excuse me. So I've popped the LCR meter onto capacitance, and we've got these polyester capacitors. These are usually pretty good. This is supposed to be 100N or 0.1 microfarad if you like, and that's coming up on the LCR meter at 103 nanofarads, so that's absolutely excellent. Let's get another one of those just to convince ourselves. This one should be what have we got here, 47,000 PF theoretically. I have a strange way of marking them. Yeah, that's coming up as 48.5 nanofarads. It should be 47. So yeah, that's perfectly all right. And then we've got this quite large one here, which is 0.22 microfarads supposedly. The reason they're so big, by the way, is because they're quite a high working voltage. Not that it matters for here, but it would for valve equipment. That's coming up at 206, marked up as 220. So yeah, that's also fine. So they're good. Got no complaints there. And then we've got these capacitors here that are sort of the weird ceramic things. That's marked up brown, black, red, which should be 1,000. So, and I think that should be 1,000 picofarad if I recall right. Yeah, and it's coming up as 976. So yeah, that's fine too. Now I've already tested these. So yeah, I'm happy with everything except those brown resistors. The coils check out, and the transistors I'm now going to just pop you onto a slide so you can look at the results I've got from the transistors. Okay, finally from a component point of view, we've got the transistors mounted on that little bit of circuit board, and both the transistor types are NPN. They're pretty much general purpose. The BF194, these are the results taken straight off the tester. I've got a BF194, and I've also got one BC148, which gives these results. The 194 incidentally is a slightly higher frequency one than the 148, but there's not a great deal in them really. Now of course you can still get these things. They're probably old stock, but you can certainly get them. But if you pop a 2N2222 onto the tester, you get results that look like that, and as you can see, that's very similar to the BC148. So I'm going to use a 2N2222 as a bit of a substitute, and hopefully that'll work okay. We'll see. Right, let's now go and build the circuit and see what we get. Okay, here we are then with circuit A1 laid out on the pegboard to the best of my ability. You've already seen one or two close-ups taken from here on the slides, and I went for the simplest circuit, which is just a 2-transistor amplifier. It's supposed to be a phono amplifier for amplifying from a record deck. I've got the record deck symbol there, and I've substituted for now this. Well, actually it's a transducer from a pair of headphones, and I've put a 150 ohm resistor in series with it just to make sure the output impedance is something like. Now on the real McCoy, we'd normally have the front board on, but I just wanted to check this out, so I've not bothered doing any of that so far. So I've omitted the on-off switch, which is part of the pot, and I've just got the pot line on its side there wired in, the volume control. And ordinarily we'd be using the battery pack with for a 9-volt supply here. I've got the bench power supply, that's negative, that's positive. It's currently on, set to 9 volts, and it's drawing about it's drawing 12 milliamps at the moment. So a nice sensible quiescent current. So just to test that things are working, remember I said there was a missing transistor when I was looking at the components. That's the BC148, and here it specifies a BC148 too. I'm actually using the BF194 here just for now. I figured that would be fine in the first stage of the amplifier, as indeed it would appear to be. So I've got a signal here about 1500 hertz, 1600 hertz, and I've got 50 millivolts from the signal generator, so a fairly low signal, and I've got it. This is the input here through that through this capacitor. So I'll attach that, and we'll hopefully be able to hear some amplification. Now I'm hoping you can hear that punching through on the mic. Certainly is there. If I'd got the correct speaker in here, I'm sure it'd be a lot louder. And then if I just apologies for putting my hand across the picture. If I just turn the pot down, you can see it does indeed adjust the volume. So yeah, that seems to be working just fine, which has proved, yeah, it's possible to perhaps try and build something a little bit more ambitious now. And although these two resistors were both reading slightly erroneously, I've included them anyway just to see what we were getting. So the only component on here the only two components on here currently that are modern are this resistor 10k and this 10 microfarad electrolytic capacitor here. That's all there is that's not original. So yeah, seems to be doing the job nicely. Let's just stop that annoying tone. And you may also recall I mentioned there was a missing transistor. So what I've done, I've taken a scrap of Veriboard. Probably the hardest job here was filing 4 slots to allow the Veriboard to fit the same footprint, and I've now wired in a 2N2222 general purpose transistor here, and I've twisted the body of the transistor round so that it is oriented in a similar way to the way the drawing is, to just remind me. And I've done the same thing. I've got emitter on connected to 2 connections, and collector here and base there. So what I'm now going to do while I've got the circuit set up is I'm going to pop this in place of the BC148 and just see if we can still hear the tone. I'm expecting we will, but we'll just try that. So by the magic of filmmaking, I'll come back when that's done. Here we are back then with the replacement transistor installed, and I do appreciate that aesthetically it's nowhere near as pleasing as the original, but just for the purposes of checking it out, I'm sure it'll be fine. Bench power supply is on. It's still saying about 12 milliamps quiescent, so I'm going to just apply the 1600 hertz tone again to the input, and yeah, as you can hear, that transistor is doing the job just fine. Hopefully you can hear that. I tried to pick a frequency that would cut through. Yeah, that seems to be working fine. There we go. That's my poor Morse skills. Very good. Okay, so there you go. So this has given me the confidence to perhaps now attempt something a little bit more ambitious, which will be for another video. Well, there you've got the Philips Electronic Engineer 1003 edition from about 1970, and I've been enjoying myself no end, revisiting my childhood. It seems in one sense like a very long time ago, and in another those 55 years seem to have gone in no time at all, as there's some bits of the kit are very familiar indeed. Others I've sort of had to relearn again. So now what I plan to do, having made sure things work, is I'm going to try and make something a little bit more ambitious, probably a radio, because radio has been an interest of mine pretty much all my life as well. And if I can get the radio to work, I'll make a video of it, so I'm going to inflict that on you too. Thanks very much for watching. Look forward to seeing you on the next video.